Today we're going to look at the effect taxes have on supply and demand. We're going to look at two specific kinds of taxes. The first one is a specific tax. This is a fixed amount that is given to the government regardless of the selling price. And this is typically a tax that the consumers don't actually see. This is something that goes along with like gas or cigarettes or alcohol, some number that you actually don't see when you purchase it, but the supplier gives to the government. The other type of tax we're going to look at is a sales tax, and this is a fixed percentage of the selling price that is actually paid by the consumer. Now what's interesting is the specific tax will affect quantity supplied, and that's because it affects the actual supplier. They're the ones sending this money to the government. You as the consumer don't see it. A sales tax will affect the quantity demanded, and that's because you as the consumer are seeing this number and therefore less likely to purchase something at a higher price. So let's see how these affect supply and demand. But first, just recall that we found equilibrium when supply equal demand. So in this case, we would say equilibrium price would be 30 and quantity would be 40. And this simply came from the idea that we solved this equation, as we discussed previously when we were looking at supply and demand. And so for this instance, like I was saying, if you solve this, you would get P, or our equilibrium price, to be $30 and our equilibrium quantity to be 40. Okay, so let's keep that in mind for this next example, because what we're going to do is take this example and build on it. All right, so using that example, let's say a specific tax of $5 is put in place. And remember here, we previously had equilibrium price of 30 and equilibrium quantity of 40. So let's see what happens to those two numbers if we put a specific $5 tax into this example. As we previously discussed, the $5 is not going to affect our quantity demanded, but it is going to affect our quantity supply. So here what's going to happen is the price is actually going to be reduced by $5 for our supplier. So Q will equal 3 times whatever price they sell it minus 5. So what I've done here is I've replaced with P minus 5. And that's because, say they sold this thing for $25 or $30. The government's actually going to take $5 away. But our quantity demanded, that's not going to change. That will still be 100 minus 2P. Because you're not going to actually see that difference in price. So now the equation that we're trying to solve is 3P minus 5 minus 50 equals 100 minus 2P. And if we solve this equation, if we distribute in 3, we get 3P minus 15 minus 50 equals 100 minus 2P, or 3P minus 65 equals 100 minus 2P. And hopefully you could solve that from there, as we previously have done problems. And what you would get is that P actually equals 33. In other words, our new equilibrium price is $33. The quantity, and remember we can take P and plug it back into either equation, it doesn't matter. The quantity would be 100 minus 2 times our new price, 33. And if we solve that, we would actually get here that quantity is 34. So what that means is previously the consumers were willing to pay and the producers were willing to sell this item for $30. But now, with this increased tax, the price is going to be $33 and only 34 items are going to be sold. So if we want to think about how much the consumer is paying now in addition, remember originally the consumer was willing to pay $30, but now they're paying a price of $33. So in this case, the consumer is paying an additional $3. So the producer, in addition, is actually conceding something here as well. Remember, previously, they were going to have to give back the government $5. So if they're selling them now for $33, and their consumers absorbing $3 of that. Of the $5 tax, the consumer's paying $3, and so the producer is actually giving away $2 of that tax back to the government. So how much is the government collecting? Well, remember, they're getting $5 for each unit. So they're going to collect $5 times the new quantity, times now 34 units are being sold. So the government is actually collecting $140. So our last example now is we want to see what happens if we impose a 5% sales tax. And keep in mind, in our previous example, the equilibrium price, as we stated, was $30, and the equilibrium quantity was 40. But now we're imposing the sales tax, which isn't going to affect our quantity supplied. That's going to stay the same. What's going to be affected is our quantity demanded. And that's because you, the consumer, are actually paying this amount. So you're paying a greater price. Q equals 100 minus 2 times, if we think about what's happening to the price, you're paying an additional 5%. So we're going to say that's 1.05p. If you think about that, if you paid tax, a 5% tax on, say, a $30 item, how would you figure out the total you would pay? You would pay 1.05 times the $30. So that's where that number comes from. So now we're trying to solve the equation 3p minus 50 equals 100 minus 2 times 1.05p. And so we're going to distribute this 2 in. 3p minus 50 equals 100 minus 2.1p. We're going to add that 2.1 over. And so 5.1p minus 50 equals 100. If we add 50, 5.1p equals 150. And dividing by 5.1, the new equilibrium price will actually be $29.41. And the reason I'm rounding that to 2 decimal places is obviously that we are in money, so we want to round out to the nearest hundredth. So that gives us our new equilibrium price. If we want to find the new equilibrium quantity, then Q would equal 3 times 29.41 minus 50. Q equals 88.23 minus 50. So Q equals 38.23. Now, depending on what it is that we're talking about, we may want to leave it as a decimal, like say we were talking about gallons of gas or something along those lines. But if we were talking about a specific item, then we might want to actually round that if it's not something that you could have a portion of.